Professor. This is Sumi. I want to talk about my final project of the my topic is reliability evolution of the power grid under the extreme weather conditions, and I want to talk about the reliability evolution method at first. And because the extreme weather mainly affects power transmission system in ways of damaging transmission lines, so the proposed method obtains a reliability index of a power system by calculating the probability and the consequence of multi-concurrent transmission line failures in selected region under different weather conditions. So considering the N1 and N2 criterion, the multiple outage of three transmission lines assumed as a main failure in the proposed method. And based on the principle of probability, the reliability evolution index is defined as a sum of products of the consequence and the probability of all transmission line failures may happen in selected region. We can see that in this function where E is a reliability index of selected region and X is a set of all three transmission line multiple failures that may happen in the selected region. And Px and Fx are the probability and the consequence of the failure respectively. First, I want to talk about the consequence of the failure about the Fx. The consequence of failure is defined as a shading load of the whole grid due to selected transmission line failure, which is the rated power of nodes isolated from the original system and can be determined by measuring the electrical distance to the swing bus. And also the second is the probability of the failure, Px. We can see in the first function, the Pi is the failure probability of selected transmission line, which is different under different weather conditions. When the system is under normal weather condition, the main reason of transmission line failure is overload or overprotection. And a hyperbolic function model is used to calculate the outage probability based on the apparent power of transmission line. But but according to the severe weather, we need considering the main reasons of transmission line failures on the several weather or the damage of transmission equipment, and no reliable model of the transmission system under extreme weather condition is achieved. So we get the second function. In the second function, where the Wt is the wind speed at time t, and alpha is a scaling parameter, and design wind speed and constant failure rate during normal weather condition of transmission line I. So in the conclusion, the index of the reliability evolution is an expectation of the amount of load shedding in the system under certain weather condition. And the proposed method can show the operators in the RACS level and the disaster areas of the system and correct the calculation results immediately when updated information is received. So we can state one case. I I did a one case about the Guangdong province in China. Guangdong province is located at the south coastline of China with subjects to the typhoon in the summer, which is a severe weather, right? Due to its geographic location and the subtropical monsoon climate, typhoon and rainstorm are the main weather disasters of Guangdong province. Statistics shows that the Guangdong province is attacked nearly 10 times by typhoon from the July to September every year. And according to the simulation, I divided the Guangdong province into the 36 regions based on the geographical locations, load and control areas. There are 1,655 transmission lines and 108 generation units in Guangdong power grid, and the peak load is 82.75 gigawatts. Typhoon Island in east is maybe the probability is 60%. The southeast is 30%, and the mid south is 10%. And also the reliability index for a single region under three weather condition I divided is three levels. The level one is about the bad weather condition, the two, the worst weather condition, the third, the extreme weather condition. And also I choose three different level region in the Guangdong. The you can see in the red picture is number 3 and number 24 and number 34. This is the reliability evolution of the single region from the function we get in the in the ahead slide. So we can see that the reliability index under bad weather condition and the reliability index under worse weather condition and under the extreme weather condition. And also, I want to talk about the reliability index under the typhoon, the severe weather. For typhoon case, considering the maximum design wind speed of the 220 kilowattage and 500 kilowattage transmission lines usually 25 meters per second. And the boundary of the three weather condition level are 25 meters per second and 39 meters per second. And the probability of the failure for each line and faculty is often using weighted summation of historical data under different weather conditions. So we want to assuming the typhoon passes over the region from the 24 to 28 from the picture. And we can get the typhoon center location in region 24 about the reliability evolution. We can see that the reliability index is 475.92 is a red alarm. It's a extreme weather condition. And also we can see that maybe from the typhoon from the 24 to the 26, the reliability is decreased from to the 57.84 is a it has been changed into the yellow alarm. And maybe in the 28th, the reliability changed to the 0.78 is not so the typhoon has no has a little bit influence on the region 28. So this is what I get from the simulation about the typhoon in Guangdong province. So the conclusion is that the typhoon nearly dissipates when it arrives at region 28. Only region 28 is affected and the weather of it is just a normal heavy weather condition. So the simulation result above show that the severe weather on a small scale won't have a great impact on the whole power grid, and the low evolution index also show that the Guangdong power system is stable at the last stage of the typhoon. So that is my that is all. So thank you, Professor.